What if I told you there's a kind of computer being built right now that doesn't just think faster, it thinks in an entirely different way? Today, Daily Amazement is here to help you understand what is quantum computing, a kind of machine that could unlock new medicines, unbreakable encryption, smarter AI, and even help fix climate change. That's not science fiction. That's quantum computing, and it's real. But what is quantum computing? How does it work? And why could it change your life in ways you've never imagined? Let's break it down. No PhD required. Let's begin at the start. What is a quantum computer? Computers we all use today, your phone, your laptop, even the one sending a rocket to Mars. These are classical computers. They process information using tiny switches called bits, which are either a 1 or a 0. Think of it like flipping a light switch, on or off. Now, quantum computers use something called qubits, short for quantum bits. And here's where it gets weird. A qubit isn't just a 1 or a 0. It can be both at the same time, thanks to a strange rule of quantum physics called superposition. Imagine you're flipping a coin. Normally, it's either heads or tails. But a qubit is like a coin spinning in the air, not one side, not the other, but both at once. And when you add multiple qubits together, something even more powerful happens. Entanglement, a quantum connection so strong that changing one qubit instantly affects the others, even if they're far apart. Together, superposition and entanglement allow quantum computers to handle incredibly complex problems, not by brute force, but by exploring countless possibilities, all at the same time. Now let's compare classical versus quantum. What's the difference? Think of a maze. A classical computer goes down one path at a time, checking each route until it finds the exit. A quantum computer, it takes every path at once. Classical computers are amazing for tasks like browsing the internet, editing video, or running apps. But quantum computers are built for solving massive problems. The kind of problems so complex, we can't solve them today. Even with the most powerful supercomputers, we're talking trillions of variables, way beyond human calculation. So, what will quantum computers be able to do? Let's look at some real-world examples. Medicine and drug discovery. Quantum computers could simulate how molecules interact at the atomic level. This means faster discovery of vaccines, cancer treatments, or even cures for diseases we haven't solved yet. Cybersecurity. They could crack today's encryption in minutes, but also create quantum-proof encryption that's practically unbreakable. Climate modeling. They could simulate the entire Earth's climate system to find real solutions for global warming, like carbon capture tech or optimized energy grids. Traffic optimization. Quantum algorithms could control smart cities, adjusting traffic lights, self-driving cars, even delivery drones in real time. Material science. They could help us create new materials, super efficient batteries, lighter and stronger metals, or even quantum-engineered clothing. Artificial intelligence. Quantum computing could make AI smarter, faster, and more efficient. Imagine personal assistants that truly understand you, or AI doctors that analyze your health better than any human ever could. What does all this mean for you? Right now, it might sound like this is all happening in a lab somewhere. And that's true. Quantum computers are still in the early stages. But fast forward 10 to 20 years, and quantum computing could be everywhere. Your phone's AI assistant might use quantum-powered servers to answer your questions before you even finish asking. Your doctor could design a treatment plan using your exact DNA, all simulated by a quantum engine. Your car could plan the fastest route, avoiding every red light and traffic jam in real time. Your power bill could drop thanks to optimized energy usage and quantum-designed materials that waste less energy. And your kids, they could be learning quantum concepts in school the way we learned multiplication, because it'll be part of everyday tech. It won't replace classical computers. Instead, it will work alongside them, handling the problems we simply can't solve now. So, who's building these machines? Several global tech giants and startups are racing to create the world's first commercially useful quantum computer. IBM, one of the earliest pioneers. IBM has already built working quantum computers you can test online, and they're aiming for a 100,000 qubit system by 2033. Google, in 2019, Google claimed to achieve quantum supremacy, solving a problem in 200 seconds that would take a normal computer 10,000 years. They're pushing to scale up fast. Microsoft, taking a unique approach with topological qubits, aiming for more stable, error-resistant quantum machines. D-Wave, believe, a Canadian company using a slightly different kind of quantum system for optimization problems already in use by NASA and Volkswagen. Rigetti, IonQ, PsiQuantum, startups with huge ambitions, some aiming to build full-scale quantum computers by the end of this decade. And let's not forget China, which is making huge strides with government-backed labs and large-scale experiments in quantum communication. Now, let's be clear, quantum computing isn't easy. These machines are extremely sensitive. Qubits can decohere, lose their quantum state, just from a tiny vibration or a flicker of heat. That's why they're kept in super-cooled fridges at nearly absolute zero. And they make lots of errors, so researchers are working on quantum error correction, which adds even more complexity. It's like building a computer out of bubbles, powerful but fragile. But progress is happening fast, and once we crack the code, everything changes. Quantum computing isn't just another step forward, it's a whole new frontier. We're standing at the edge of a revolution in how we solve problems, understand our world, and improve life on Earth. It won't happen overnight, but when it does, it will touch every industry, every country, and every one of us. So the next time someone says, quantum computing, you'll know they're not just talking about computers. They're talking about the future. If you enjoyed this video, hit like, subscribe, and turn on notifications for more deep dives into the future of technology. Drop a comment. What would you use a quantum computer for? Thanks for watching, and stay curious.